Hello everyone, and welcome to this online session on qualitative comparative analyses. Today I'll be explaining and going over what a QCA is, how to use them, and I will be doing that according to myself together with Rock last year. Now, I would suggest we just get into it and see uh, where we end up. So let's first discuss what led up to me performing a QCA. As part of my PhD, I mapped 20 European Union member states in terms of autism and education policy, which meant that my PhD was very monotonous in terms of research design, and the output was exclusively qualitative. Now, what I did have were 20 to 30 case studies, if you will, each member state or education system, each with unique attributes and all mapped with the same methods. So after a PhD meeting with Kasia, we explored some options of diversifying the research designs in my thesis. And after a talk with Rock shortly after, a QCA was recommended to kind of compare the 20 to 30 case studies that I had mapped anyway. Really tied the whole package together, if you will. Now, what is a QCA? A QCA is a mixed method approach that uses a medium number of cases, usually between 10 and 50, to and you, and uses set theory and Boolean minimization to reach its outcomes. It offers an alternative approach to causation. That I have to be very careful with the word causation. I'll get into why at the end of the session. Because it considers the presence of variables in outcome situations. And presence of variables meaning different variables and how they can work together. Therefore, it acknowledges that variables do not work in isolation, which is something that is very commonly seen in quantitative methods such as regression models, where you have to introduce like a specific effect modification if you want to account for the effect of two or more variables working together on an outcome. A QCA typically uses case studies as data, and the variables or conditions are classified as either necessary or sufficient. Now, a necessary condition indicates that the condition is okay. A necessary condition indicates that a condition is crucial to reaching the outcome measure, although a necessary condition on its own is not enough to produce that outcome measure, whereas a sufficient condition is, although a sufficient condition produces an outcome rather inconsistently on their own. So you can see how how in a QCA you need both to consistently and reliably reach an outcome. The sufficient condition offers the environment in which the necessary condition can thrive to, in tandem, build the outcome measure. Now, a QCA output can be characterized in, I guess, technically three types of solutions, but I'll be discussing two in this session, namely the complex solutions, which just make use of the data without taking into consideration any prior knowledge or theoretical difficulties, and the intermediate solution that can exclude certain variables or conditions that may be contingent on other conditions, or may be excluded for other reasons that are available in the literature, really. Then at the end, there are various iterations of a QCA, namely crisp set and fuzzy set QCAs. A crisp set analysis indicates that the data set only consists of binary conditions and outcomes. A fuzzy set analysis indicates that there can be multiple levels in the variables. Educows used a fuzzy set analysis, and I'll be showing you the distribution of variables later. There are 5 steps of performing a QCA. First, you have to choose a suitable data set in which variables and outcomes are recorded. Then you have to calibrate the data according to your statistical software. So I personally used R, and it offers a very simple command to calibrate the data, although you have to consider whether it is a fuzzy variable or a crisp variable. Then there is an analysis of necessity to indicate the necessary conditions. I suppose between the analysis of necessity and the analysis of sufficiency, you create the truth tables, but I always consider that the step in the analysis of sufficiency. So you create a truth table, which you then minimize to determine sufficient conditions. And finally, you do an assessment of consistency and coverage in the models that you found. Then the pathways or outcomes that are sufficiently consistent are compared back to the literature. I guess this is where you could kind of infer a sense of causation, because the case studies tend to have a longitudinal approach. I say tend to, because it's not a given. I'll always look at the nature of your case studies before you make any inference of causation, and be very, very careful with that. I can't stress that enough. Now, let's talk about the QCA that I performed with ROC. First, it was determined, and we had to determine what variables we would include. Now, the QCA, as I said, was based on the policy mapping articles that I wrote prior to this. Based on literature, we found that the disability rights and education model indicated important conditions to include in the QCA. We looked at some more literature, specifically the systematic literature review by Van Michem and colleagues from 2018. And we identified 8 variables that were also recorded or were very much present or often covered in the policy mapping papers. So those were the establishment of a definition of special education needs, the right to education for children with SEN, support staff, support for teaching staff, general support services for children with SEN, the presence of inclusive education policies, parental involvement, individualized learning outcomes, and mixed mainstream classrooms. As outcome, we took the degree of access to education, which we divided in 4 levels. Now let's look at how exactly these variables were coded. So this table is directly from the paper that is currently under review. I will leave a link to the preprint later in this presentation. So the condition established definition of SEN was coded in a crisp way, either no or yes, and the criteria for yes was whether a proper definition of SEN is established through policy. Now, when you look at, for example, the support for teaching staff condition, you'll see that it has multiple levels of membership, either none, scarce, or elaborate. In that case, it is prudent to determine when something is considered scarce and when it is considered elaborate. So in this case, scarce support is indicated by either the presence of additional teacher training or supporting staff, such as teaching assistants. Elaborate support is indicated by the presence of both factors. Now, looking at the outcome, we used the levels set out by the 4th comment on the Convention on the Rights of Persons with Disabilities in 2016, namely exclusion, segregation, integration, and inclusion. Exclusion being children with SEN are completely excluded from the education system. Segregation involving the situation where children with SEN can follow education, but removed from, I guess, children without special education needs. Integration indicating classrooms where children that can conform to those classrooms are allowed to participate in them. Children who cannot are still divided, segregated in separate institutions. And inclusion where every child is included in the same classroom regardless of SEN. Now, let's look at how I performed the analysis. So for software, I use R. For those who may not be familiar with R, if you want to use it, you have to both install R as well as the RStudio application, which gives you access to the interface in which you can work with R. We use the QCA package, and we tested 6 out of 7 variables. The right to education, as you can see as the second condition here, was excluded because if you look at the criteria, it was considered yes if the right to education for children with SEN is established through policy, and this was the case for every member state included in the analysis. So the condition was rejected by the calibration. It did not pass the calibration, therefore it was not included in the analysis. First, we did the assessment of necessity. We determined that a condition was necessary when the consistency was greater than 0.90, which is a value found in the literature. We used the super subset command using the calibrated data set and using the calibrated access to education variable string as outcome. And for conditions, we used all but the right to education. We used the calibrated versions of all the conditions except for right to education. We determined the fact that we were looking for necessary conditions by indicating necessity as the relation, and the inclusion cut was set to 0.9. As output, R gave us this. Well, they gave us more than 3 lines, but these are the most important lines. First, you see that the support services for children with SEN has an inclusion of necessity of 0.97 and a coverage necessity of 0.632. Whatever this RON variable is, I knew it at one point. It's honestly important for this analysis. So based on this output, I would argue that we would have 3 necessary conditions. However, if you look at the third line, you see that it is the interaction between support services and mixed mainstream classrooms. Now, since we're looking at individual conditions at this point, this last bit is not, this third line is redundant. We're not interested in that. So if you want to read this properly, you look at the first and the third column, telling you respectively the consistency and the coverage that we're interested in. And as I said, even though the interaction is over 0.9, because it is an interaction, we don't include it as a necessary condition. Next up, we constructed a truth table. We did that using this code. In this code, we saved the truth table command to the vector tt1. Truth table command made use of the calibrated dataset, used the calibrated access to education line, string, variable, however you want to call it, as the outcome, and as conditions it used, again, all the other calibrated conditions except for the right to education. We used an inclusion cut of 0.8 or a consistency of 0.8, which indicates a moderately strong association with the outcome measure. We also constructed a complete truth table where the not observed potential pathways were also included. It is not mandatory to do this, but this was just my personal interest to see what potential pathways could have been constructed. This was done by adding the complete equals true element to the truth table command. Now, once the truth table was constructed, we printed the complex and the intermediate solutions by minimizing the truth table. As you can see in this piece of code, the complex solution, which was saved to the vector complex sol, is a minimization of truth table 1, in which details were shown. According to literature, individual learning plans or individual learning outcomes were contingent on other variables that were also in this analysis. So we decided to do an additional analysis of intermediate solution, removing the individual learning outcomes as a variable. I suppose I should address the include equals question mark. This was part of standard code. I would have to get back to you on whether this was. If you're interested in that, do let me know. It was part of the sample code that I used to construct the intermediate solution, though. Never really questioned it, to be honest. Now, the complex solution gave this outcome, which is a lot in terms of, it's a very busy outcome. There's a lot going on here. Well, let's look at it first. Let's start with what how to read the lines. So the first line indicates a lack of definition of SEN, combined with a lack of teaching support, combined with the presence of support services, combined with the presence of inclusive education policy, combined with the presence of mixed mainstream classrooms, is the first pathway. So the little dash indicates an absence, and the condition itself indicates the presence. This goes on and on and on. Now, the interesting bit is that in every one of these pathways, you see the presence of support services for children with SEN and mixed mainstream classrooms. These are our necessary conditions. And when we're filling in the table later, you'll see that these are not actually included in the sufficient pathways. I'll give you an idea, an example of how to note that down in a couple slides. Now let's look at what columns to focus on in this case. It would be the first and the third. First being the consistency, and the third being the coverage. So the first line has a consistency of 0.68, which is lower than 0.8, so would be removed, and has a coverage of 0.339, which indicates that, well, a reasonable, like a few cases use this, or this pathway was found in a few cases. More interesting, though, is if you look at the bottom, you see Model 1 and Model 2. Model 1 having an overall consistency of 0.743, and the second model having an overall consistency of 0.811. Remember that we used a consistency threshold of 0.8. So based on this output, we are not going to use the first three lines indicating the first model. We are, however, going to use the second model, except for line number 4, because its individual consistency is lower than 0.8. Now, then the intermediate solution. Intermediate solution had a model consistency of 0.733, which was insufficient for the for being included into this analysis. Sorry, my train of thought just ran away from there. Don't really know what happened. Anyway, uh, this model is not included because its model consistency is not higher than 0.8. Also, to make our findings a bit more robust, Rock was asked to independently recode all the data set basically without my input to see if my coding was correct and if I assigned the correct degree of membership to all the variables. So he went through the policy data and determined whether he agreed with whether the right to education was present, whether the access to education was as present as I thought it was. Basically, I guess a double check of the data, of the raw data. This is the output table that was ultimately included in the article. As you can see here, before we go into that, I have no idea why it says necessary causes. It should say necessary conditions. I'll get onto that. I'll do that probably before final publication. But as you can see here, we have two necessary conditions: general support services for children with SEN and mixed mainstream classes. I said earlier that those would not be included in the sufficient pathways. And as you can see, they are not. But in a way, they are too. Because the necessary causes are mentioned first, you can interpret it in a way that those little stars where necessary, the little stars at the necessary causes are present in each and every one of the sufficient causes. But because they're necessary causes, conditions, I'm going to mess this terminology up, aren't I? Because they are necessary causes, they need to be mentioned specifically. In terms of consistency and coverage, looking back at the complex solutions, you'll see in the consistency column, the first one, that the consistency ranges from 0.948 and then 11111 to a coverage of 0.374 and then ranging from 0.61 to 0.148. The solution or model consistency and coverage are also mentioned at 0.966 for necessary causes and 0.811 and 0.691 for sufficient conditions causes. Again, you know what I'm talking about at this point. Now, how do I interpret these results? We found 5 causal pathways that were sufficient to be included in this model or in this analysis. Because the EU member states unanimously implemented the right to education for SEN, that variable was excluded. So we were left with 7 conditions that can affect access to education. But before we go into how to interpret this, let's look at some limitations. First, in order to perform a QCA, the cases should be similar. So data should, the methodology in which the case data was gathered needs to be similar. The cases need to be comparable. Sometimes that means that cases need to be generalized a bit in order to be comparable, which may run the risk of losing some uniqueness of the case. For example, maybe a certain policy works in certain circumstances because of cultural or demographic factors that are not included in this analysis, but that uniqueness of the policy kind of gets lost in translation. So do be careful with that. Second, QCA is not a quantitative method, so it cannot account for false positives, which again makes determining causation a very, very I don't want to say dangerous, a very tricky thing. You have to be very careful with your um, with how you phrase it. And yeah, as I said numerous times actually, conclusions of causality should be made very, very carefully because QCA identifies pathways within a data set. The QCA in and of itself is a cross-sectional design. You have both the conditions and the outcome at the exact same time. Now, the fact that that this data was gathered over time can give you some sense of causation, but again, causation taking very lightly. You could phrase it as a strong inference, or you could maybe phrase it as like a trend that is observed. But whether that is grounds for causation, that needs further research. It is a very good exploratory methodology to like determine what pathways and what mechanisms should be focused on in future research. Now, after considering these limitations, the results can be interpreted properly. In the paper that we wrote, each pathway is given its own explanation. And in this presentation, I will walk you through how the first pathway is included, or how the first pathway is explained and explored. For the other pathways, I refer you to the preprint, which can be found at this DOI. Yeah, to those who are in the are in my leadership group, you have this DOI in your module book. Maybe you can share it if people want to read it. Also, you can just Google the title, I suppose. Now, how to interpret this? I'll give you a second to read the text on screen. Basically, we identified the pathway and then went back into the literature to see if such interactions have been observed and whether these could be explained according to known literature. Please also see that we made use of a combination of policy, research, and kind of, I don't want to say ground research, but practical research that explored the practical situations in order to give a rounded view of what was going on. Now, after each pathway is individually explored, it is very prudent to check for peculiarities across pathways. So in this case, for example, it was an interesting finding that support for teaching staff was present in 4 out of 5 pathways, and that the presence of inclusive education policy was also included in all the pathways. But neither of these factors were necessary conditions, which means that these conditions kind of set the stage, but can't give the performance on their own. And it is very important to recognize that these conditions are so prevalent in so many pathways, because that does give you an inclination of what to focus on in terms of policy recommendations, where the desire is there, but the desire to build a certain environment is there, but you need to give recommendations on what capacities need to be present in that environment in order to have a chance at developing the, I guess, wished for environment. Now, let's discuss some pitfalls that I fell into along the way. The big one is the first one. So it says measuring an outcome does not mean you can measure the lack of outcome by mirroring and flipping the outcome variable. What do I mean with this is that in the initial drafts of the QCA, there was another analysis that basically flipped the coding of the access to education outcome upside down. So let's go back real quick. Basically, the way it's coded now, exclusion 0 to inclusion 3. We had another outcome measure called lack of access to education, which had inclusion at 0 and exclusion at 3. And for a while, I was under the impression that this could identify barriers to access to education. But as it turns out, that's not really the case, because by doing so, you look at you're going to investigate what variables actively move um, an inclusion environment to an exclusion environment. You would develop an exclusion environment moving away from an inclusion environment. You wouldn't see, it's not that you see what variables actually work against an inclusion environment. You look at variables that work for an exclusion environment. Now, those may be similar, but still, after some consideration, it was not. We considered it not. We considered it a bit dodgy to include in this analysis. There we go. Also, again, I hope you've internalized this by now. QCA does not report causality. You have to be very careful and very delicate with your phrasing of causality in a QCA. I guess the main reason for this is the lack of statistical significance and the difficulty in accounting for false positives. So you, again, make an inference, but be very, very careful. In my article, I talk about associations and correlations more than I talk about causations. I guess I talk about causations a little bit, but I did explain what I meant by that. As long as everyone's on the same page, it's fine. It's just that by using the word causality or cause, it's very easy to misinterpret that. So really be careful about it. Be careful with reporting causation. Well, it was a short one. Thank you for listening. If you have any questions, you can you can email me at the email address shown on screen, or you can ask Rutgers, who may or may not be present at the time of our lecture. For a while, I was under the impression that he is, but recently I get the impression that this lecture is just thrown online and questions can be asked later. So, in any way, there are channels to ask questions, and we will be happy to take any questions and try to answer them as well as we can. Thank you for listening, and good luck with the rest of the course.